So in this chapter, in this course, we'll study the basics of energy and the consequence of where we get our energy from. And so in this chapter, we'll start off with energy basics and some of the physics principles involved in it. All right, so we'll talk about the various forms of energies that we encounter. Uh, we'll look at some of the laws of thermodynamics which affect how we get our energy. We'll talk about heat engines, which comes under therm- thermodynamics, and we'll talk about the Carnot engine, which is an ideal heat engine, and we'll see how electricity is currently generated. All of our electricity is mostly how all of our electricity is generated. Electricity is the most convenient form of energy. A lot of our work gets done using electricity, and so we'll see how it's generated. All right, so it turns out energy is a big part of our life. It's estimated that $1 out of every $10 is spent on energy. That's 10% of everything is spent on energy. So, for instance, the world GDP is about $75 trillion today, and so we spend about $7 trillion on energy, but the cheapest source of energy, and that means fossil fuels. Okay, so these are 2015 numbers. Almost 85% of world's energy come from fossil fuel sources like coal, oil, and natural gas. That number today is about 80%. But anyway, so a majority of our energy comes from fossil fuel sources. Now here's the punchline for this course. So the use of fossil fuel, when we burn fossil fuels, we release carbon dioxide in the atmosphere. And carbon dioxide causes global warming. And so that's the problem. So for instance, the world temperature has risen by over 1 degree Celsius since early 1900 or 1900. So because we are getting our most of our energy from fossil fuels, we are raising CO2 levels in the atmosphere, which is causing global warming. Okay, so that is the problem. So here are some world energy use. Worldwide, annually, the world uses about 10 to the 20, so 6 times 10 to the 20, we'll say 10 to the 21 joules of energy. And this is about 540 quadrillion quads, and one quad is 10 to the 15 BTU. Okay, so here's another unit of energy. Anyway, the world uses 10 to the 21 joules of energy, or 540 quad. Now in the US, we use 100 quads annually. So roughly we use 20% of the world's energy, and we have 5% of the world's population. So what that means is if everybody in the world use energy the way the US does, uh, we have 5% of the world's population and 20% of the world's energy. We need 4 times this energy. The world would need 4 times this energy. And that would be 2,000 quads. So, of course, that's not possible. Anyway, so we'll talk about all of that. So, the worldwide average energy, average per capita energy, annual per capita energy is 8 times 10 to the 11, 10 joules, which is roughly 10 to the 11 joules. Okay, so per capita, it's 10 to the 11 joules per person. And the total energy use is total energy uses about 10 to the 21 joules per year. And this makes sense. There's about 10 billion people, well, 7.5 billion people, but let's say 10 billion people. 10 billion people is 10 billion people is 10 to the 10 people on Earth. So, and 10 to the 10 times 10 to the 11 gives you the total energy used. All right. Okay. So we've already said this. Most of our 80% of our energy comes from fossil fuels. Now here's why we use fossil fuels. They're relatively inexpensive, and the main reason is they have a high energy density. So what that means is per pound they have a lot of energy. Okay. So it doesn't cost us too much to transport it from one place to another. And anyway, so our infrastructure is built to use um, fossil fuels. So an enormous infrastructure has been established for the location, production, and use of fossil fuels. So what does the future look like? Say 50, 100 years from now, 200 years from now. So the question we need to ask ourselves is, how long will our fossil fuels last? We have all this infrastructure set up for their use, and and a more important question. And so we don't want to be using this now. Is it easy enough to switch from fossil fuels to renewable sources? And we'll answer that question over the course of this course, but we'll give you a preview in a few minutes. Okay. So of course the answers are not simple. So the answer to the first question, uh, okay, so the fossil fuels can last anywhere from 40 to 1,000 years, depending on how fast we use them. For instance, if we continue using 80% of our energy needs, uh, the fossil fuels will not last too long. So of course, what we are doing is we're starting to use more and more renewable energy, and the fraction of our energy coming from fossil fuels is decreasing. Okay. So to answer the second question, what is the environmental impact of our fossil fuel use? There's overwhelming evidence that the emission of greenhouse has a severe impact on the environment. So the magnitude and time scale of this impact is not fully understood, but we know it's impacting us. Now, also we know this, if we continue using fossil fuels for an extended period of time, then the ability to mitigate the effects of the effects on the environment are not also unclear. So what we're saying is the damage we cause, maybe we won't be able to undo that in the future. So what we're saying is it would be best for us to wean ourselves from fossil fuels as fast as possible. You know. So anyway, so future energy sources. Uh, so for the because we are warming up the planet, it's essential that steps towards eliminating our dependence on fossil fuels be taken immediately. So we as a humanity need to develop and bring online alternate energy sources so the environmental impact of our fossil fuel use is minimized. And the alternate energy sources are really the renewable sources like solar, wind, and nuclear are the three main sources. So we need to bring solar, wind, and nuclear online as fast as possible. Now let's look at some of the numbers. Let's look at what it would take to make the world go on renewables completely. So here are our typical numbers. Uh, a large electric generating station has an output of 1 gigawatt. So Hoover Dam is, for instance, the Hoover Dam has a generating capacity of 1.34 gigawatt. But as Hoover Dam, and with 1 gigawatt, you can roughly run a million U.S. homes. 1 gigawatt is a billion watts. So, for instance, with a billion watts, you could here's what you could do. Here's a 100-watt bulb times 10 to the 7 equal to 10 to the 9. So with the gigawatt, you could light up a 10 million 100-watt bulbs. Okay. Anyway, you can run a million US homes. So now let's figure out what it would take to make the world completely run on renewable energy. Okay, so to put the magnitude of the task into perspective, so the world power requirement is about 18,000 gigawatts. So to run the world, we roughly need 18,000 Hoover dams. That's what that number means. So let's say in 50 years, a probable time scale for substantial reduction of fossil fuel use. So what we're run on renewable sources. In 50 years, by the way, our energy needs would be 36,000 gigawatts. These are all rough estimates. Hopefully not. Hopefully this number will be smaller, but anyway, just to get ballpark numbers. So in 50 years, living standards would be higher, the population would be slightly higher. Um, so mainly living standards will be better. So that's the energy needs we'll need. Okay, so this is a rough goal that should be kept in mind while we're evaluating energy policy. So in 50 years, the world, let's say, requires 36,000 Hoover dams, and hopefully, if we want to run all of that from renewable sources, here's what will need to happen. Okay, so the conversion to a complete non-fossil fuel economy over the next 50 years will require the construction of 36 large power plants. So 36 large plants. Okay. Um, Today, the cost is for a gigawatt of generation capacity costs in the range of $1 to $3 billion. So, and this is a non-fuel fossil fuel plant we're talking about. So, a solar power station or a windmill and stuff like that. Now, these costs will, of course, come down over time, but so let's say will 1 gigawatt cost $2 billion to build. Renewable 1 gigawatt generating capacity costs, let's say, $2 billion. So if the world were to switch to a totally renewable economy in 50 years by 2070, that's an investment of $4 billion every day for the next 50 years. So, to build 36,000 gigawatts of renewable energy plants, will be needing to invest $4 billion every day for the next 50 years. Okay, so that's what it would take. Now, this is no easy task, and it will require a substantial commitment on part of all governments. Okay, so we'll stop now.